Hello students. Today we'll be continuing discussion with the future and today's topic is ecology and future cities. And today we'll be covering the overview and the biotechnical horizon. Then we will come to the indigenous knowledge systems and we will go for a case study with the visions of 2050 and eco futures of India will be the last segment of this today's lecture. If we try to recap on the urban ecology, the historical phases, as you remember, we discussed ecology in the city. That was the bio inventories created in the pre-CBD era, pre-CBD era in 1970s. Then we could see ecology of the city, interactions were the focus, and now in 2020s, ecology for the city, action is in the focus. So we can see every 2 decades the focus of our urban ecology is also shifting as the urbanization pattern is also changing very drastically. And this urban ecology that is built on blue green infrastructure, environmental engineering or ecological engineering, and now scales to the transdisciplinary co-production. So it is neither core area for a planner or any ecologist. Everyone, including the governance, need to really work together. Transformative turn came knowledge action spirals in urban sandboxes. Urban sandboxes is a new term we are introducing today. It actually tells us about a bounded urban setting. Like you take a corridor, neighborhood, or a ward, or a campus, or you can create a digital twin also where you can actually allow certain freedom. They are free from certain restrictions which actually on ground happens. So that allows the temporary regulatory flexibility. Real time data collection can happen and stakeholder co creation to experiment with innovative urban solutions. And the best part of urban sandboxes is that if your experiments are actually meeting any failure, those failures are not a drawback of your project. Rather, these failures are going to teach you a new lesson, and that is an input into the process. So, for iterative testing, citizens labs, this urban sandboxes is a very common model for today's time, which are very, very relevant for urban ecology experimentation. And its evidence is very much there in European pilots. We can see twice the resilience of these cities, those parts which are under these experiments, they have gained resilience via the inclusive nature based solutions. So, this is urban ecology has really gained a traction. Urban ecological challenges in 2050. The imperative is like that global urban population will increase by 2.5 billion. India's burden, as already we are having the largest population, we are having a projection to add 416 million urban dwellers by 2050. You just imagine the number. And 90% of growth of this global urban population is concentrated in Asia and Africa. Biodiversity pressures 1.8% hotspot loss by 2030 because whenever you are having this urban population increment, then there will be certain development and that is to be adjusted by the loss of biodiversity only. That's the most common thing happening. Urban sprawl converts 45,000 square kilometer of farmland by 2050. Like in India, Western Ghats or Himalayas will face 10 to 15% of forest decline from expansion. Climate vulnerabilities, already we are experiencing them. Heat islands amplify 3 to 4 degrees Celsius in the nights. Flooding losses 4 billion US dollar per year, doubling every decade the loss. So it's a non-linear equation. Equity, informal settlements, they bear 70% higher risk than the other residents. Mumbai is facing potential sea level rise damages, which may be costing around $50 billion by 2050. And the social dimensions are less than zero point 0.5 square meter green per capita in 14 out of 24 surveyed cities, and exacerbated the health disparities. 71% is heat stress hours have been added. Why ecology for future cities? The foundational role, we can see that urban ecosystem assessment can play a very important role as a base. Planning using the prior tools like BGI, etc., can be there. SETs and SETI for adaptive future needs and outcomes can be applied. So, in all these uh, phases, we can see that ecology can play a very important foundational role. Co-production closes gaps, 20 to 40% better equity in US cases. We can see projections for 68% global urban by 2050. In India, 951 million urban, 328,000 heat deaths per year without the nature-based solution. So these are the type of projections which is demanding action. So 0.4% GDP we can gain if we go for the greening way. So that is the opportunity which we can actually remember when we go for the action. Policy alignment, SDG 11, Smart Cities 2.0, Amrut 2.0, all of them they foster good Anthropocene via regenerative designs. So threats are enormous, but we can also look at the solutions. And ecology is one of the very strong contender to be partner with the future cities. So from the sanitary to the regenerative, it's a very strong shape. We have discussed it in details in our previous lectures. The sanitary city, 19th, 20th century, typical British influence. Nature is nuisance. If you are having water, drain it. And waste, if you are having, hide it. That is the principle. Linear metabolism, take, make, and waste. The sustainable or resilient cities, that is the current phenomena. We are discussing it, we are applying it. Net zero is our goal, neutral impact, not to create any impact on the natural resources. And the focus is on efficiency, bouncing back from shocks, resilience. The regenerative city, the future goal is net positive. Mechanism, cities that actively repair the biosphere. And the question it raises, the future one, that is, can a building generate more energy than it uses and clean the air around it? These are the type of questions one is raising. And as we have discussed the SETI in our previous lecture only, so I believe we can always then explore the science, technology, engineering, how they are responding back and helping the cities to respond to these type of questions. So the social, ecological and technical system framework, which is going to be one of the core for futures, and this framework can be defined as an integration of social equity, ecological health and technical innovation for holistic resilience system. And this framework can actually support many different type of couplings like social ecological. We have seen justice in the greens, that is social ecological coupling. Similarly, social technical, so many inclusive apps are there, and AI monitoring of the greens or blues, that can be a very good example of eco technical coupling. So all these improvements, this ACT system is actually advocating, is having a very strong emphasis. And we can see lot of advancements are happening, like temporal deep futures. 2100 scenarios are being simulated. So, this is unthinkable even a decade back. And spatial continuum, urban rural links are getting lot of emphasis on today's time, because urban areas are spoiling these links as well. So just to protect these particular rural areas, we need to also think about the linkage. The benefits of this ACTS framework: it reduces the vulnerabilities by 40% if we can have the socio-ecological and technical coupling. It has been shown, it has been established by flood modelings also. Scenario planning for multi-hazards like New York City's co-developed visions is very good example of this ACTS framework. And we have discussed also this particular framework in our module 7, lecture number 33. You can go back and look at the details of it. Relational urban ecology, there is a shift from structure to relationship, and which focuses less on objectives like buildings and parks and more on flows and relationships. I was mentioning this urban sandbox where all different stakeholders, you can see the planners, residents, designers, humanists, engineers, science, business owners, artists, anyone and everyone, they are coming together. They are discussing the social problems, ecological problem, and the technical problem. And this social action and the interdisciplinary knowledges, continuously they are having these exchanges. So if these are having the rural areas and this is the urban areas where the problems are being faced continuously, the challenges, the deep future talks about that continuously it shall evolve further, and that which are not yet cities, they also have certain different types of activities so that they can grow well. So the urban sandbox concept, which I had introduced in previous lecture as well, a space for experimentation, constructed absence of regulation, when knowledge flows into action, action flows into knowledge spiral. As I was discussing, that every time we do some activities here, it may fail, it may pass, no issue. Everything can come as an input, and continuously we can keep on learning, and that is going towards the deep future, because you are handling so many different scenarios at one time using the technology. Iterative co-production involving scientists, citizens, and planners. This spiral is knowledge spiral is continuously evolving, and application has been seen testing a new waste to biogas system in a specific ward before the city-wide rollout. So you are checking a pilot project, and whatever challenges you have faced there, you try to smoothen it out, and then you go for city-wide rollout. We will also discuss the circular economies, because ecological loops are very important for future cities. Linear metabolism, at present also several cities are exercising this, who are consuming 75% of natural resources and producing 50% of global waste. If we have to manage the waste and if we have to have a curb on natural resource consumption, we need to shift towards the circular economy. So, future mechanics are circular urban metabolism. Waste to resource, urban mining yields biodiversity credits like 30% impact reduction. Role of ecology, this will close the teleconnections, sequesters via compost networks, etc. And the projections of this type of circular economy applications are 71% of solid waste management emissions can be cut by 2050 with anaerobic digestion. In India, there are a lot of good potentials, like Nagpur has a 190 MLD wastewater reuse for industries. The challenges, again, the scale, informal recycling equitably, these are the things very important. because previously also I discussed about the scaling up is a very strong challenge for innovation. The biotechnical horizon, uh, we will come back also to the building level in when we discuss this part. AI driven biodiversity management. Challenge is urban ecosystems are too complex for manual monitoring. So AI and computer visions can be a very good solution for that. The framework advocates like monitoring, real-time tracking of species, conservation, predictive analytics for habitat connectivity, and outcomes are enhanced ecosystem services. Digital twins focused habitats track biodiversity in real time. 40% uncertainty can be reduced using these techniques. So these are the future tools for the cities in future. Applications, flood and heat simulations like Chennai's hazard maps. Tech enhanced evolutions, we can check on that. Digital twins, planning precision. The function of digital twins is to simulate eco impacts pre-built standard in India by 2035. Benefits 50% faster iterations like Surat's multi-hazard twins, and it can be integrated with a CTS for equity audits. So social and ecological as well as technical systems can take care of the equity as well. NBS 2.0 multifunctionality, deep futures via co-created hybrids, which we were mentioning in previous case. High number of scenario you can create. So sensor and greens, that coupling can be there. Evidence, two times gains in resilience. We have seen the Steimerbeek Valley in Netherlands. They have experimented with this urban sandbag 10-year spiral. Within 10 years, where they will go. Principles are iterative labs, addresses injustices like 90% diverse leadership. Synthetic biology and mycelium architecture, we can shift from the fabrication to the growing of building medium. Mycelium, the fungal roots, that they can bind the agricultural waste like straw, sawdust into strong composites. The properties, fire resistant, insulating, biodegradable, carbon sequestering, they are the properties of this mycelium. In the Indian context, also, we can really seriously think about it, turning crop stubble, that pollution source, into building blocks. And in many advanced labs, like in France, also, they are actually working on this mycelium, which they are using in the as the medium for insulation, and it is actually it is going to be very lightweight, as well as performance targets have been set and against which the experiments are going on. And you can see here a very nice example of the hi-fi project. Algae building technology, another advanced technology, bioreactive facets. Glass panels are filled with microalgae cultures. How they function? Dynamic shading. Algae grow faster in sun, so they provide the shade. Energy, harvested biomass for the biofuel or heat, and thus it actually can curb on the mm, fossil fuel. Carbon capture, 1 kg of algae biomass is equivalent to 1 kg of CO2 captured. So the equivalency is quite strong. And BIQ House, Hamburg, is a biointelligent quotient building. BIQ in Hamburg is a very good example, world's first algae powered building. So every time we can really look at this type of inspiring examples. Biophilic design, human nature coupling in future. Affinity for nature enhances well-being. Biophilic smart cities by 2040 is the concept. The projection is 25% health savings plus 15% productivity in green offices. And Singapore and other cities are really working for it very earnestly. Visual links, refuges, dynamic light, ICT for real-time feedback. These are the elements which has been always part and parcel of this type of experimental buildings. This biophilic design can also be a very strong imperative in the resilience side. Crisis stress reduction, post flood recovery, they can be very helpful. Regional analog like Park Royal Singapore is having 20% energy cut via the Sky Garden. In the Singapore airport also we can see that world's largest indoor waterfall and over 10,000 plants which is taking care of water recycling as well as creating the biophilic nature. Multi-species urbanism, the core philosophy is that the city is not just for humans. So we are discussing so many different concepts. They are at present only at pilot building stage probably, but gradually we are hopeful that we will find their applications more rapidly than not. The right to the city, extending rights of non-human residents like birds, pollinators, microbes. That is the philosophy. Ecological labor, recognizing that trees cooling streets and wetlands cleaning water is infrastructure work that requires supports. So, ecolope, ecological envelope, designing building schemes as ecotones transition zones. You can see the Bodo Happold and the Cook Fox architects, they have developed a living facade for the birds and insects and creating specific niches like bat roosts, rough texture for moss, cavities for sparrows. So many different species who can really survive better in the cities. Urban rewilding, it's also a very common initiative by now. The objectives are boosting the wildness, trophic diversity increment, minimal intervention for functions. The objectives are boosting the wildness, improving the trophic diversity, and minimal intervention for functions. The projections is something like that 15 to 30% biodiversity by 2030, co benefits for health or climate. The strategies are native reintroduction networks like grassland and over the lawns. These are the initiatives. Globally, 2025 studies show widespread benefits in 50 cities. There are different stages you have to really opt for if you are choosing or your city is choosing to go for urban rewilding. You have to conduct the site assessment and community stewardship is required to scaling it to the city networks by 2050 is the target. The challenges are balancing density and power sharing in co-management. This is always having a human dimension, so governance becomes an issue. Now we'll be moving forward to discuss the indigenous knowledge system. And we will see that how indigenous knowledge system can fuel the future, the ancient future. The premise is indigenous systems are not past. They are time-tested resilient sciences. Decolonizing planning, they can help in. Moving away from gridiron or British models to localized hydrological approaches can be a very, very strong contribution from IKS. Indian urbanism cannot merely import Western or East Asian models. Most of the time, we simply say this, but we don't try to explore how to do the other things, do the things differently. We have to look inward to the sophisticated ecological engineering of the subcontinent's past. Like we can integrate hybridizing the IKS with modern sensing technology, smart plus sacred. That can be our mantra. Like we can go for the RUSA system, the vertical zonation. RUSA system is a very common system in the northeast. It's a farming system. What it does, it actually understand the local people. They do understand that high plots and the lower plots at the lower elevation, they are having different potentials. So accordingly they divide this particular area into upper tier, middle tier, and lower tier, and they decide how to have the development in these three tiers. Like as I was discussing, it's an indigenous practice of Northeast India, three-tier land use based on the gravity. The uppermost one, they go for the forest, water catchment, and this is protected, sacred, so that it can absorb the initial rainfall and it doesn't really contribute a lot to the lower part. Middle part, habitation, livestock, nutrient capture. So that is the habitation one, and one is allowed to bring disturbances there. The lower part is the agriculture one, rice, fish, and the sinks. So whatever waste is getting generated into the very first year, which is pristine in quality, the second tier, which will be waste sort of thing, polluted sort of thing, that will come to the lower tier and that will be actually absorbed. The sinks, it shall have a sink effect. Urban application, future zoning can strictly reserve high grounds for sponge landscapes like forest, middle grounds for habitation, and low lying floodplains for wetlands and water treatment, strictly prohibiting the type of floodplain encroachment seen in cities like Chennai and Amravati. Let us move on to another very important indigenous knowledge, that is the sacred groves, community conservation. The concept we can find in many places in India. I am just bringing examples from Kovikadugal, Oran, or Devarakadu. They are the patches of forest protected by religious taboo or community governance, and similar concept, as I said, it is also available in Chhattisgarh, in Jharkhand, in Northeast, in different names, managed by local communities through cultural and spiritual norms. That is very important, the spiritual and cultural norms. The ecological value of these pockets, the sacred groves, are they are having a very high biodiversity managed by local residents or the ward committees, providing carbon sinks and microclimate regulation. And native species are there. The urban strategy, community conserved areas can be there within the wards managed by residents, not the state forest department. State forest department will have a very less understanding about this community knowledge. So it is always better to go for the community managed committees for this type of sacred groups. We can see the similar initiative in the water sector as well, water heritage, tape wells and tank cascades. Heating and cooling phenomena in this tape well, you can see that pavilion stone domes are there. So once it is heated up, hot water will go up and then water will be drawn inside. Water will be drawn inside and they will go through the water and the air will be cooled. So the people who are inside, they will get the cool air. So you please study this image also. The revival of Bauli tape wells, all of us, I think we know about them very well by that time. And the tank cascade system, ARI system of Tamil Nadu is critical. We have seen this system not only in Rajasthan or Tamil Nadu, it is probably everywhere, either in the way of connected ponds, or in these tanks, even in Andhra, in Madhya Pradesh. In almost all the states, we can find this traditional water heritage. Complex social infrastructure that recharged groundwater and cooled the surroundings microclimate. ARI, the tank cascade system of Tamil Nadu, it is a chain of tanks where overflow from one fills the next. Step wells reimagined as thermal refuges, passive cooling public spaces, and we have also discussed the very similar thing like ARI system of Tamil Nadu for the Warangal city, if you remember in our previous module. Now we'll be discussing the case studies for the visions of 2050 First one is the Dholera Special Investment Region in Gujarat, India. India's first platinum rated Greenfield Smart City, twice the size of Mumbai, envisioned as a global manufacturing hub, located in low lying mudflats, Gulf of Khambat. Flood vulnerability, very high risk from the sea level rise and storm surges. So, the criticism is reliance on hard engineering, concrete embankments versus the loss of natural mangrove buffers. So, sustainability claims urban sandbox, 5,000 megawatt solar parks, zero liquid discharge, ICT enabled plug and play infrastructure. But at the same time, recognition to the natural ecosystem is very minimal. That is also need to be noted in this case. Case study 2, Biodiversity, Penang, Malaysia. BIG, Bjork Angels Group, they have designed it. Three artificial islands as an urban mosaic. Key features of this biodiversity is biomaterials like bamboo, timber, green concrete, mobility, car free, autonomous water and air transits, and the mangroves, wetland buffers for carbon sequestration. Four times more efficient than the forest. That is true, mangroves are much more efficient in carbon sequestration, and especially in these coastal areas, they are the best buffer. Land reclamation, the project requires massive sand filling, and that is the conflict. Ecological trade off, creating new terrestrial habitat at the cost of existing marine benthic ecosystem. So that's the conflict. So the debate is it regenerative if it destroys the seabed? I think you have to guess the answer. Case study 3, another conflict, Eco Atlantic, and this is from Africa, Lagos, the capital of Nigeria. The vision is the Dubai of Africa. This is protected by the Great Wall of Lagos, and the stretch is 8.5 kilometers sea barrier, and it has been criticized very strongly as it is actually creating a climate apartheid. I think you remember this term apartheid when we had a different world, let's say 3 decades back or 4 decades back. South Africa it was ill famous for this term apartheid. So now you just see we are creating again the apartheid, this time against the climate, a fortified enclave for the wealthy who are protected from the sea level rise by that Great Wall of Lagos. The seawall deflects erosion surges to neighboring poor informal settlements. If it is not happening here, then it will happen where the wall ends. There, the scouring will happen, the storm surge will come. So, you are placing the problem to somebody else's code. You are relocating it. So, the model which they have adopted in this Eco Atlantic is the privatized resilience. Safety is a commodity, not a public good. Again, we can have a debate on it, definitely. So, students, we are coming to the last segment of today's lecture, that is Eco Futures in India. The policy directions, the frameworks which we get from the Niti Aayog, the pilots mandate the ACTS in plans and fund rewilding like Ponchgaon model and degraded to thriving. This is something we are actually looking at very seriously, that initially the pilot projects are working very nicely, but how it can be nurtured so that it can go for scaling up. We can see Amrut 2.0 is focusing on circularity of water. So the recommendation will be something like that: biophilic audits, international ties. This can really help towards the new future where ecology can get its due. Financial mechanism, we discussed it a lot, like municipal green bonds, payment of ecosystem services, they are helpful. Key implementation challenges are there: institutional silos, the funding people are always having a doubt on this ecological thing, so it cannot really attract the funding as the gray infra can gather. Equity in peri-urban areas, it has always been seen not only in peri-urban, even in urban areas, 70% losses are for the poor only. Biodiversity policy, if we try to look at how it can help, it can really help the nature. Biological diversity rules 2024, that mandates biodiversity management committees. I think we remember BMCs are a compulsory component now in urban wards to document local flora and fauna. Nagar Van Yojana, that also we discussed, target to create 1,000 urban forests by 2027 to act as a carbon sinks. And green building footprints. We had good discussion on the footprint, handprint. So you can see this one that India now has the second largest green building footprint globally. 13 billion square feet registered with IGBC. There are the green, this Griha. There are other agencies also who are registering these green buildings. Smart versus ecological, the Smart Cities Mission 1525. The status is 100 cities with integrated command and control centers. The gap could be identified like success in digital spines but often neglected ecological lungs. So the criticism is like this: despite these technological gains, reports are indicating a significant neglect of ecological planning. Many projects prioritized aesthetic retrofitting over deep climate resilience, resulting in encroachment on wetlands and loss of tree cover in cities such as Patna and Tiruvananthapuram. So these are very, very important or significant gaps which we can find in smart city mission programs. The development must pivot from smart infrastructure to smart ecological infrastructure. That is something we are advocating. Decentralized power models, very interesting energy pivot we can actually see in today's time. Modhera, the solar village in Gujarat, is the first solar village in India which is having 24/7 net zero, uh, but fully connected with the electricity. 6 megawatt ground solar plus 15 megawatt hour battery storage. That is the combination, that is the amount of energy they are generating. Zero electricity bills. Residents are earning income by selling this excess power to the grid. We can also see its application, this energy, solar energy concept application in very important projects like Cochin International Airport. There, this Cochin International Airport Limited, they are decided and actually been able to construct the first fully solar powered airport. The innovation is agrivoltaics. They are growing 40 tons of organic vegetables under the solar panels, so the spaces are not going waste. The scale is something very, very interesting. Capacity has been expanded to more than 50 watt, mitigated 200,000 plus tons of CO2. So, this is also a very important contribution through this intervention. So, we would like to see now the opportunities, the actionable pathways. We can find the synergies between the technology and the ecology, like AI, NBS. This combination, this coupling can really help in 50% efficiency. We can combine AI and smart tech with indigenous wisdom. We talked about the ancient future. This is probably that ancient future. Co design for justice, we have seen the Bangkok flood resilience. The student role, we discussed again and again that these young brains can actually contribute. Their thesis, their any dissertation work, though these can be the pilots for rewilding or any other ecological steps in aspirational districts. Advocate 30% canopy mandates, leverage 2025 partnerships in these aspirational districts. You can integrate the ecology in the urban core. So the inference can be that ACTS, biophilia, and rewilding, these are the concepts which are proven that can enable regenerative India, balance technology with the co production. That means it's not only technology but also the community. These are something, this handholding will be changing the governance side, uh, and bringing the innovation for sustainability, will help this future cities to be more ecological one. So today we have discussed the basic context of these future cities, biotechnical horizon, indigenous knowledge systems, case studies, visions of 2050, and ecofutures in India. These are the references, and thank you.